Today, Node.js is one of the major platforms for the web. Enterprises like Uber, Netflix, Autodesk, Intuit, and even the NASA are using it for important parts of their business. With over 4 million weekly downloads, Express is the most commonly used web framework to use with Node.js. Due to its minimalistic approach and ease of use, creating websites with it is easy and enjoyable. After completing this course, you will be able to build out dynamic websites with Express end-to-end. You will also be able to use and transform any HTML theme you find online into a dynamic page. You will even learn how to create API endpoints to create single-page applications. I invite you to join me on my LinkedIn Learning course, where you will learn everything you need to create a website with Express. There is some knowledge you should have to get the most out of this course. You should specifically and most importantly know a little bit about Git. So you should have a Git client at least installed, and you should be able to use it on the command line. You should know some HTML and CSS. That makes sense because we are building a website and we will also manipulate HTML and CSS to some degree here. You should know JavaScript basics like how to declare variables, how to use functions, and callbacks. You should also know some basics about Node.js, like how to build a simple application and how to run it. You should also be familiar with new features of JavaScript that came with ES6, like let and const, like arrow functions, and also you should have some basic understanding of async await. In our library, you find a variety of courses that help you gain better understanding of all these concepts. Everything else from installing the required software to configuring the sample project will be covered during this course. All the files for this course are freely available as GitHub repo at this URL. I assume that you have a Git client already installed on your machine and have some basic knowledge about what Git and GitHub are and how they work. If you're completely new to Git, I'd recommend to take the course Learning Git and GitHub by Ray Villalobos. As Git and GitHub are so commonly used, I promise that this is a good investment into your career. The repository is built so that there are branches for each of the videos in this course. You can use the branch pop-up right here on the left to switch between the different versions. If you see a B at the end of the branch name, this means this is how the code looked at the beginning of the video. And if you see a E, this means this is how the code looked at the end of the video. And the master branch, so that's the initial state, this is how the code looked at the very beginning of this course. I also created a separate branch final that contains the final stage of the course. To download all the files to get started, you have to clone this Git repository, and I will show you now how you can fetch all those branches. If you want to make changes and commit them back to GitHub, you may also fork this repository and clone it from there. I will now clone from this repository, so I click on this green button and select clone or download, and I select this HTTP URL. And then here on the right side, you have this little button to copy this URL. Next, I will open a terminal window, so I run the terminal app on my Mac. On Windows, there is something similar available. And in this terminal, I will now create a new directory for this course material. So I run make directory building dash website dash Node.js dash express. And then I change into this directory. And now I'm doing the actual cloning of this GitHub repository. And this is way more complicated than you might think if we want to get all branches. So I run git clone dash dash bear. And then I paste in the URL that we copied before. And then in the end, very important, I add .git. Next, I'm going to run git config dash dash bool core.bear false. And then I run git reset dash dash hard. And at the very end, I run git branch. And as you see, now we have all those branches of this course available. If I look into this directory, I see that I have now all files of the master branch ready. Going forward, we will use Visual Studio Code, which has a very good Git integration. Let's install it along with the rest of the development environment used for this course. Before we really get started, let's make sure that you have all the tools needed on your machine. First, let's install an editor. In this course, I will use Visual Studio Code. It's free and it comes with great Node.js support out of the box. I highly recommend that you use it as well, at least for this course. To install it, use your favorite search engine to look for Visual Studio Code. Click on the download link for your operating system. I have it installed already. Let's open it right away. File, open. And as you know, I placed the exercise files on my desktop, so I open it from right there. Visual Studio Code comes with great Git integration, and here on the bottom left you see that we are currently on the master branch, and you also see that when I click on that, I can switch between all those different branches freely. So if I want to see the end of chapter 3, video 3, I just switch into this branch. But to get started, make sure that you stay on the master branch. Visual Studio Code comes with an integrated terminal that lets you run shell commands. Let's open it by selecting View, Terminal. And let's see which Node version we have installed here on this machine. So I type Node-V, and you see that I have installed 12.13. That's the currently long-term supported version of Node.js. If you got an error now, this means that you haven't installed Node.js already. So to install it, just head to the Node.js website and install the currently long-term supported version. With that all set, you should be ready to now really get started with this course. Ready to jump right in? Then get ready for some hands-on coding. To kick this off, we will create a minimal Express application from scratch. We will keep extending that application throughout the course. Different than other platforms, Node.js has an HTTP module built into its core. Express utilizes the HTTP server in this core module, and at least during development, you don't need to set up a separate dedicated web server to run Express applications. Let's see how this works. I already have Visual Studio Code open, and the only Node.js specific thing is the package.json file and the package log.json file. Those are needed to maintain dependencies of our current project. Now I will open the terminal that comes with Visual Studio Code by clicking View and there Terminal. And let's first install Express. So in the terminal I type npm install Express. This will pull down Express and all dependencies and add it to our project. And you see already in the package.json, this dependency is now here on line 14. Next, I'm going to create a file for the server we are going to build. Let's call it server.js. So in the root of my directory, I add a new file, server.js. And there I will first require Express, so add const express equals require Express, and then I have to create an instance of Express, which is actually our application. So I add const app equals Express, and note the parentheses there. This is because we're executing a function here. Next, I define a port. So this is the port that the application should listen to. Usually web servers are listening on port 80, but it's a convention that Express servers usually listen on port 3000. Next, we need some route that we can open in the browser. We will learn more about routes in great detail later. Just for now, stay with me and add app.get, and this is for the slash route, so that's the index route. And I have a callback here that takes a request and a response object. And in the callback function, I now want to send something to the browser, and there is a method for that on the response object, so add response. And when I enter the dot, you see already that Visual Studio Code helps me with auto-completion, so it's response.send. And I want to just say hello, Express here, and let's add a friendly smiley. So whenever this route is called, this should be sent to the browser. And in the end, we also, of course, have to really start the server and tell it where to listen. So I now add app.listen, and I add the port as first argument, and it again has a callback. This will be called as soon as the server is listening. And there now I add console.log, and I'm using backticks here because we're using string interpolation. And in there I add Express server listening on port dollar and in curly brackets the port. Let's try that out. So in my integrated terminal, I will just now type node server.js, which will use Node.js to execute this file. And it looks good so far. It's at least running, and I'm opening my browser. And in the browser, I now head to localhost 3000, and we get a Hello Express back as expected. That's it. This is a basic Express server. Of course, we've got much more to do, but some important building blocks are in here already. Our central goal is to build a dynamic website from a static template using Express. In our project, you find a folder called Provided, and in there is a folder called Static. Let's first drag this folder into the root of our project. When I look into the folder, I see that it consists of some HTML pages and also a folder for CSS styles, one for images and one for JavaScript. Let's look into the code of the index.html file real quick, and we see that right on top here at line 6, it loads Bootstrap, a CSS framework that gives us some good default styles and offers a grid system to create responsive websites. We will see what this means in a second. I now want to see how this page looks like in the browser on my Mac. For that, I can now simply right-click on this index.html file and select Reveal in Finder. Depending on your operating system, you should have something similar here. And here on the Finder, I can now select Open with Google Chrome. So what you want to do is you want to open the index.html file in your browser. So we see that we are going to build some page for a conference. It's called Rue Meetups. And the index page consists of a so-called hero section. That's the section with the large picture on top. Then we have a navigation, a list of speakers. And when we scroll down, there is some intro text and we have a sidebar that shows artworks made by the speakers of our conference. And if I click on such a picture, we see that the page uses some JavaScript to open a large version of it. Before I talked about that this page is using Bootstrap to make this page responsive, and when I now reduce the size of my browser window, you see what this means. So responsive means that depending on the size of the browser window, it will adapt and it will also even hide sections the smaller we get, as you see here. Let's look at the navigation. So we have home, speakers, and feedback, and speakers is a drop-down. And when I click on all speakers, I get to a typical list page where I see more details about the speakers of the conference. Our designer got lazy here and just copy-pasted one section to just emphasize that this is a list. This is also very common. When I click on the speaker's name, I get to a speaker detail page that now contains a large picture of the speaker along with some more details, so the whole bio of the speaker. And on the right sidebar, I have now just the artwork that this particular speaker created. Let's also click on feedback. This leads us to a typical page that contains a form to submit feedback and a section that shows feedback provided by others. You might now wonder why we even want to use Express here. This is a perfectly functioning website. We just need some web server that will serve it. So why do we need Express? Well, imagine that just a speaker changes. So when I'm here on home, I have to change a speaker. So I will do this now on this top speakers bar and also in the speakers navigation. And I, of course, also have to change the speakers detail page. That's very redundant. Dynamic websites let you avoid such redundancies by using central templates that contain the layout of a page. Or let's look on the feedback page. We want to be able to submit feedback and also see it instantly on the page. This is also only possible using dynamic websites. We can see that there are many good reasons why most websites we see today are dynamic and not just use static HTML. Let's proceed by taking the very first step towards a dynamic site by letting Express just serve static HTML as any normal web server like Nginx or Apache would do. Let's teach Express to send static HTML pages to the browser. This is not yet what we understand as a dynamic website. It's more what a regular web server does. It receives a request for some URL and serves the right page for it. To accomplish that, let's open the server.js file, and there I want to change the existing default route to read and send the HTML file to the browser. To accomplish that, I have to add one more module to this server.js file, and it's a core module called path. So I add const path equals require path. We will see why in a second, because and there in my default route, I first remove everything what's in there, and I start typing response. Visual Studio Code already suggests send file. So this is a function on the response object that lets us send a file to the browser. And I have to now add the path to this file. And for that, I use the path module. And there I use the join method that helps me just create a proper path reference. And as first argument, I'm using underscore dir name. That's a constant provided by Node.js that contains the current directory. And as second argument, I'm now adding dot/static and their index HTML. Should be pretty clear what we're doing here. So we are creating a path reference that points to the index HTML file in the static folder. We also have a speakers HTML file. Let's serve this as well. So I now copy this route, and now I use the path speakers. So under/speakers, I want to serve now the speakers page, and there I just have to change index HTML to speakers HTML. Let's start the application now by typing node server.js, and I'm heading to the browser, and in there I want to open localhost 3000. And we see that this is pretty good already, but the page misses all images and pretty much all styles. So the styling that you see here now is basically provided by Bootstrap, and Bootstrap is loaded from an external URL. If we look into Chrome Developer Tools, so on the right-hand side, there is 3 dots, and there I can select More Tools and Developer Tools. And when I open the Network tab and reload the page, we see that the page fails to load all the static files, like all the speakers, images, the style, CSS files. So pretty much everything that is static. Let's see how we can fix that. So I'm back in Visual Studio Code. There I see in the static folder that we have the CSS images and JavaScript files in here, but Express now has no way to know that it should serve static files from there. For that, we have to add a new so-called middleware that is called static. We will learn more about middlewares later, but for now, let's just use it. So before my routing handlers are defined, I will now add app.use, and the middleware is called express.static. So every time you see a app.use, this is how middlewares are applied in Express. And there again, I will add path.join dir name, and other than pointing to a particular file, I'm just now pointing to the whole static folder. This will instruct Express to look into the static folder for each request it receives, and if it finds a matching file, it will send it to the browser. Now let's restart the application. Again, node server.js, and let's head back to the browser and reload the page. And we see that it now looks perfect. We can also try the /speakers route, and it hopefully will now serve the speakers page, and it does. We just created a basic Express web server that serves HTML and static files. While we will change the routes to render dynamic templates later, serving static assets via express.static is something you will need in any project. A properly configured development environment helps you avoiding common pitfalls by taking care of consistent code formatting and pointing out possible problems. I think that regardless of what you're doing, this is something you should know how to set up. For that, I'm now going to install a set of tools to accomplish that. You can use that for any other project just like that. First, I'm going to install ESLint. ESLint is a so-called linter. It uses a rule set to enforce some coding style rules and also points out common coding mistakes. For that, I now run npm install -d because it's a development dependency ESLint. And after this is installed, takes a little bit. If we look into package.json, we see that this was now added as dev dependency. This means if we deploy our project into production, ESLint should not be included. To initialize ESLint, we will use the command npx. npx comes with your Node.js installation, and it will first look into your Node modules folder to find the script you want to execute, or if it isn't there, it will even pull it down from the npm repository. We installed ESLint already, so when I now type npx ESLint --init, it will take the init script provided directly by ESLint, which is now in our Node modules folder, and it will give us a wizard. On this wizard, I now select that I want to check syntax, find problems, and enforce code style. I select CommonJS because that's the module loader Node.js uses. We don't use React or Vue.js, so I select none of these. We are not using TypeScript, and I can deselect the browser. I just want to use Node, and I also want to use a popular style guide, and I prefer Airbnb there. So that's a style guide provided by the company Airbnb. They use that in their projects, and this wizard will now create a config file, and I want this to be in JSON format. Next, the wizard asks me if it can install a few additional dependencies, so I select yes, and now this is installing. Next, I also want to install Prettier. Prettier is a tool that can format your code. So differently than ESLint, which is more about code style and code mistakes, this is about keeping code formatting consistent. So I'm now going to type npm install -d. Again, it's a dev dependency Prettier. And I'm also going to install 2 more modules that integrate Prettier with ESLint. So because we have to make sure that the rule set provided by ESLint is consistent with how ESLint does the code formatting later. So add ESLint -config -prettier and ESLint -plugin -prettier. So far, Visual Studio Code does not know anything about the modules we just installed. We have to install 2 extensions now. For that, I click on the Extensions menu item on the left menu bar, and there I select first ESLint, and I just select the first extension that comes up. It's by Dirk Bäumer, and I select Install. And also we want to install the extension for Prettier, and there I take the extension provided by Espen Pettersen, and I click Install. Now I want to change the configuration of Visual Studio Code. For that, I go to Code, Preferences, Settings, and there I first look for ESLint, and I select here Autofix on Save. Then I look for Save, and here you see Editor, Format and Save, and I enable that as well. And I also want to set the default code formatter now for Visual Studio Code. So I look for Format, and there you see the default formatter. And if it's not yet set to Prettier, you just select Prettier by typing Prettier in, and then you select SBMB Prettier Visual Studio Code. That should be it pretty much here. One more thing I have to do is I have to change the ESLint.json file to add the modules we installed before. So here under extends next to Airbnb base, I add now Prettier. So that's the Prettier config module. And I also have to add a new entry here, a new key, plugins. And for plugins, I will now add a new array entry that is again prettier. And I also have to set some defaults for prettier. That's another config file. And we're almost done, I promise. Now I select new file and create a file .prettier rc. And in here, I set now configuration options for prettier, some defaults that prettier needs. And as you see here, as we installed the prettier extension, we now get even coding assist for this configuration file. And for trailing comma, I want to set ES5. So that's how the trailing comma should look like for arrays. The print width, so that's the line length, should be 100. And I want to use single quotes for strings. So I select true here. Now you saw it already. When I hit save, it already did some formatting here. And when I click on server.js and I hit save, you see that it now uses just 2 spaces as indent, and it also added one more line after the last line. So that is some coding style that is enforced by the Airbnb style guide. So this looks pretty good so far. Let's try something else. Let's add some line break here that shouldn't be here. And you see when I save, it jumps back. You see that now code formatting is really enforced. And if you roll that out into a whole team of developers, you can always make sure that your code always looks exactly the same. On my pursuit to make coding as smooth as possible, I found out that it's pretty tedious to reload Express every time I change some code, as we did it before. This problem can be solved with a tool called NodeMon. NodeMon will watch our project and reload it automatically when a file changes. So let's install NodeMon now, and it's again a development dependency. I add npm install -d NodeMon, and this will install NodeMon for us. And I'm already opening package.json because I have to change the start script there now once NodeMon is installed, because I will now add a new entry that I call dev. You will see soon how we can run this then. And there I add NodeMon. And then I add --ignore. And this is now a little bit of a spoiler, because later we will store feedback user submit into a feedback.json file. And we don't want Express to reload then every time this file is changed. So I'm ignoring the feedback.json file that we will have later. And then I add server.js. This is the script we want to start. To use that now, I just run npm run dev. So that's the script that we are going to run. And we see that now NodeMon is starting up. Let's try something out, like adding some console statement here. Console log. I'm restarting. And I hit save. And you see that now the script restarted and also printed out my log statement. Let's remove that before we go on. We now have a really solid development environment in place that makes our life easier as we go forward in this course. And in the next chapter, we will look at how to use templates with Express. When building a dynamic website, there's always some static HTML that should contain some dynamic data. Let's look at an example. Imagine you have some array that contains a list of persons, and you want to output this on an HTML page. Maybe you already got the HTML from your designer. So how can we combine our data with the provided HTML? This is where template engines come into play. They always provide some special syntax to work with dynamic data. Here is an example in pseudocode. Finally, we need something that does the actual work of parsing the template file, combining it with the provided dynamic data, and then rendering it to HTML. This is what the template engine does. On top of that, there is one more reason why you want to use templates. Let's look at the website we are building. There are parts that appear throughout the sites, like the hero section, the navigation, or the gallery. Using templates, we can split our layout into reusable parts and store them in separate template files and just include them into our page. By doing so, there is no redundancy, and if we want to change the navigation, we do it at exactly one place. Modularization is another thing template engines give us. Express is very agnostic when it comes to template engines. Any engine that provides a specific interface can be plugged into the framework. Looking at the Express documentation, we see that today around 20 engines are known to work with Express. Choosing the right one is mostly a matter of preference. Most importantly, you should feel comfortable with the syntax. The end result rendered to the browser is always HTML. It's always the same for any template engine. For this course, we will use the embedded JavaScript template engine, short HES, as it's simple, fast, and powerful. I've already opened the website for the HES template engine that we will use in this course. The website contains the complete documentation, which fits neatly on one page. It also lists the features and benefits. Most importantly, HES lets you use regular JavaScript as template language, as you see here. So you don't have to learn any new syntax. The only thing that might look unfamiliar to you are the template tags. These are the brackets with the % sign. They instruct HES to parse what's in there, and there are different types. Let's look at them. The simple bracket with the % sign is used for control flow, like conditions or loop statements that don't produce any output. Add an equal sign and it will output the variable inside those tags and escape all HTML in it. If you use a minus sign, the content will be unescaped. This is when you want to render HTML that is inside a variable. There are also a few tags that deal with white spaces and new lines. We don't need them in this course, but you should know that they exist. Additionally, there are also includes. They let you include the contents of another template into the current one. You can even pass in arguments. This makes them very useful when you, for instance, want to output list elements. No worries, if something is still unclear, we will use all of that throughout this course. Now let's first add HES to our project, and I head back to my Visual Studio Code and I stop nodemon by pressing Ctrl+C, and now I will run npm install HES. This will just install the HES template engine to my project. And now I have to also tell Express that it should use HES. So in my server.js, right after Express was instantiated and maybe after the port was declared, I add app.set, and the configuration value we want to set is view blank engine, and there I set HES. You don't have to require HES here in this file. The Express will automatically discover it. And then I also have to tell Express where to find those views. For that, I add app.set, and the entry is views, and the value is path.join, and I use again __ dir name, and a second argument I now use ./views. This expects the template to live in a folder called views. This folder does not exist yet, so we'll create it now. So in the root of my project, I will now select new folder and create a new folder, views, in there. Let's restart the application by running npm run dev. So the application still works, but we don't see much of a result either. Next, we will render our first template using HES. Okay, now with HES in place, I want to use it to render the index page. So let's open server.js and let's look for the route with the slash. So I remove what I have here, and I will now use the render function of Express. So I add response, render, and render takes as first argument a path to a template, and I use here pages index. Obviously, I have to create that. So what Express is doing here, it will then look into views, pages, index to find a matching template file. As a second argument, it also accepts an object that contains local variables that will be available to the template. And I want to just set a variable that's called page title, and let this be welcome. So the page title of the index page should be welcome. Of course, I now have to also create this pages directory in Vue. So I add a new folder to Vue's called pages. And then I will move over the index.html file into this pages folder. And I also have to change the extension now to HJS. To make Visual Studio Code also recognize HJS files, let's add an extension for that. So I look for HJS, and there I have HJS language support, and I will just install that. So I get a little bit of hint syntax help by Visual Studio Code. And in this index.js file, I will now change the title to use the variable we defined before. So I add, now I have this percent bracket with the percent sign and an equal sign because I want to output something, and I want to output page title here. So this should be all that is needed to do. So let's look into the browser. And here in the browser, I just open again localhost 3000. And we see that the page is now obviously rendered using the template engine. And we also see that this page title we set as template variable is now part of the page title shown here on the browser. So far, we have learned what template engines are, and we created and rendered our first template using HJS. Next, we will look into Express routes and middlewares in a bit more detail, and I will show you how to use Express Router to organize your applications like a pro. Middlewares are key concepts of Express. Basically, everything is built around them. We already created routing middlewares that will be executed when a specific URL matches, and they end the request by sending data back to the browser. We also used the Express static middleware to support static files like style sheets or images. And additionally to using existing middlewares, we can of course also define our own ones. Let's now dive into this topic a bit deeper. First, let's look at the overall syntax. Middlewares are defined on the application object, and in general they use application.use. And they take a callback. This is what will be executed for this given middleware. And the callback gets a request and a response object, but we will see that in a bit. We can also have a pass as first argument to this app.use. This means the middleware will then be only executed if the URL matches a specific path. Again, they take a callback that will be then executed for that. And then we also have those routing middlewares. They usually use some HTTP verb, and I will cover that in a bit. But they, again, take some path and also a callback. What can Express middlewares do? They run with your request, and they can execute any code in there. They get the request and response object as arguments, and of course they can operate on them. So this means they can, for instance, change the request object to parse maybe some information that is in there and store in another variable. And they can also end the request response cycle. This is mostly true for routing middlewares, because in the end, a routing middleware will send something back to the browser and will so end the execution flow and the request. Finally, they can also call the next middleware in the stack. This means if more middlewares are defined, a middleware can pass on the control flow to the next middleware. Let's look at the general middleware first. Regular middlewares are defined on the application object with .use, and they support the callback that should be executed for each request. And this callback takes a request and a response argument and also a next argument. Request and response are rich objects with several methods defined on them. Most importantly, response gives us methods to finalize the request and send data back to the server. But we will see that on the routing middleware on the next slide. The middleware can then do anything that needs to be done. Very often it will manipulate the request or response object. Once the middleware is done, and that's important, it will call next to pass on the control flow. If next is not called, the request will hang. So every time you end up with a not loading page, most probably you have forgotten to call next or end the request in some other way. Let's look at Express routing middlewares. So in this case, we have some call to /feedback of our page. A route is a specific middleware that contains a HTTP verb. As you might know, in HTTP there are different so-called verbs like get, post, put, or delete. They are part of the HTTP protocol, and for instance, when you send a form, this is most likely a POST request. When you simply open an URL in the browser, it's a GET request. Next, we have the path the route should match against. So this route will only be executed when this given path matches. As I said before, this is also possible for app.use. So the lines are pretty blurry between those general and those routing middlewares. The main difference is the HTTP verb on routing middlewares. Then again, we have this handler function that gets this request and response object and this next object. Routing middlewares usually end the request in some way. So they will, in most cases, not call next in the end, but something that will terminate the request and send something back to the browser. And those methods to send something back to the browser are defined on the response object. For instance, we have something like send file that we used before, or to render template, we can call .render on it. So this will terminate the request, no need to call next in the end. There's one more important thing, and these are parameter routes. Express routes can contain parameters. This means that parts of the URL can be dynamic, and these dynamic parameters can then be used by the application. Think of a route that should show the page of a given conference speaker. As you can see, using a colon identifies a parameter, and the route will then match any string after speakers and store it in a variable called speaker name. And we can then use it, of course, inside our handler function. We can also prepend a question mark. This will make the parameter optional. This means it will then match /users, but also /users Melissa, and then again make speaker name available and set it to Melissa. To put this all together, let's look at the Express request lifecycle. In the beginning, the application initializes. It will execute all JavaScript code, which will register all middlewares. Then it will start the HTTP server and listen on a given port. At some point, a request for some URL comes in this case for /speakers. Express will execute all defined middlewares in the order of their creation, and if they aren't ending the request, they have to call next to pass on the control flow to the next middleware. As I said, if you don't call next here, the request will hang. If a middleware contains a path, it will only execute it when the path matches. In our example, at some point, we find the path /speakers and it matches because it's also a GET request. So this GET speakers middleware gets executed, and it will ideally then do something like response.send to send a response back to the client. Now that you're an expert on routes and middlewares, let's apply that knowledge, and I also want to show you one more important feature of Express. Until now, we defined the routes for our application directly in the server.js file. That's okay for small applications, but once the application grows, this can become confusing and hard to maintain. A good practice is to group all route definitions into a file or directory structure of its own. To accomplish that, I will create a new folder, routes, in my root folder, and in this root folder, I will create a new file, index.js. Next, I will copy that route definition for /, and while I'm here, I will remove the declaration of the speakers route. We will add it to the new routing structure in a bit, and I paste now the definition into my index.js file. Now we see those red wavy lines on the app object. That's obviously because there is no app object defined here. So how can I get to my Express application objects to define the routes on? This is where Express Router comes into place. Express Router lets you create sub-applications that listen on specific routes. To use Express Router, I will first require Express, and then I will get my router object from Express by calling const router equals express.router, and that's a function, so it ends with parentheses. So now I have a router object, and I can really now replace this app object with router, because that's very similar to an Express application, and I can define middlewares and routes on it. Right now, this module does not return anything. What I could do now is I could now do a module exports equals router, and this would then return the router object that we just defined with the route defined on it. But I want to do something else. This is something you won't find in many tutorials, but I find it very useful. I will now define a function, or I export a function by adding module exports equals, and I define an arrow function on that, and I will put my routing definition into this function. And from there, I will now return the router object. So why am I doing that? By doing so, we can pass down arguments from our application down to the route as function parameters, and we will use that later. So we just created a routing module, and now we have to mount that into our main application. And we can do that by going into server.js, and there I will first require this new routing module. So add const routes equals require dot slash routes. And as you might know, this will default to the index.js file. So this will require slash routes slash index.js. And then further down, after the Express static middleware was declared, I will now add app.use. So that's another middleware. And this middleware should listen on the slash path. So this is a catch-all for all the routes under slash. And here I will now add my routes module and mind the parentheses, of course, because we saw before this is a function, and to get the router object back from it, we have to call this function. So now let's open the page again. And as expected, everything still works, but now we have a dedicated routing infrastructure that we will build upon during this course. We just created our first routing module. Let's now go ahead and create the rest of the modules that we need to build out our whole page. I decided to organize each subpage into a file of its own. For that, I will now add a new file, feedback.js, and a new file, speakers.js, to my routes folder. Before we implement those routing modules, how should we hook them into our Express application? What I could do now is I could simply just add it here to server.js. So, for instance, do something like app use slash speakers, and then have some speakers route, something like that. But this will again add a lot of dependency to the submodules that I have. I would rather just have one point in the application where I hook or mount the routes into it. So what I can do instead, and which is way more elegant, is I can go into my index.js file and add those subpages now to that index.js file, which also resembles the overall structure of my application, because under the index page, which is slash, I have a slash speakers and I have a slash feedback. So to accomplish that, I have to require those two files I just created. So add const speakers route equals require dot slash speakers, and I add const feedback route equals require dot slash feedback. Next, I have to mount those two routing handlers. For that, I now add router.use. So very similar to what we did before in the server.js file. And now for everything below speakers, I want to use the speakers route and mind the parentheses in the end, because as we know, this should later be a function that is exported from the speakers route. And I do the same for feedback. So router.use for everything under slash feedback. I want to call the feedback routing handler. When I reload the application now, I will get an error. This is because the middleware actually expects a function to be returned. Obviously, there is no function yet because speakers and feedback don't return anything. They're empty. But I'm just showing you that so that you know if you ever run into this problem, it's most probably because you forgot to return anything from your routing handler. So let's implement those routing handlers now. And to save a little bit of typing work, I will just copy the content of my index.js file and paste it to my speakers.js file. And we can remove the require for speakers and feedback on top, and also this router use statements, obviously. And for the slash route, which is because it's mounted to slash speakers, so this means now the slash points to slash speakers, I will for now just return response send because we don't have a template for that yet. So I can simply return speakers list because the slash speakers page should return the list of speakers. I also want to create the route for speakers detail pages. For that, I will copy now this routing handler, and now I have this parameter route we talked before because I'm using now colon short name, because this is now everything that matches slash speakers slash some short name that identifies the speakers detail page that I want to show. And I will return, and mind the backticks here because I'm using string interpolation, detail page of $. And how do I get this parameter short name now? This comes with the request object because request has a property params, and this short name will be stored under .shortName. I will copy that now again and paste it into the feedback.js file. So the first route is pretty much the same. I will just change the response we sent to feedback back page. And I now want to define another route that will be later used to receive the data when someone submits the feedback form. And for that, we will now set another HTTP verb, not get. We will use post because we will send this form with post. Don't forget now to remove this short name parameter here, and I will just send a response like feedback form posted. So this should make sense for you. So we have an HTTP verb.get, which will show the feedback page. And when I submit the form against the same slash feedback route, this post routing handler will be called. And right now we will just return feedback form posted from there. As we see now, also the application is now starting properly again because we implemented the routing functions. So we can now head over into the browser and just open localhost 3000. The index page still shows up. Let's see what happens when I access slash speakers, and this shows speakers list. Now let's say there is a speaker Daniel. This would show the detail page of Daniel, and also we can just do the get request to the feedback page, and I also get the feedback page here. So that's it. We have all routes for our subpages done. As you can see, Express Router gives us a lot of flexibility to structure the routes in a meaningful way. Let's now go ahead and add some business logic that we will need inside those routes. With all routes in place, we are missing an important piece of our application. Right now, if one speaker would ask us to change their information, we'd still need to change that on various locations, like for the navigation and for the top list of speakers. Also, how should we collect feedback and show it on the feedback page? We want a central place where all the speakers' information and all feedback is stored. We need a way to retrieve this information to render it into our templates. In any dynamic website, you will find some kind of business logic. As this is regular JavaScript code and not really related to Express, I've already prepared classes that will give us that. You find them in the provided folder in services. So to get started, let's move this services folder to the root of our application. Also, there is a folder data that contains the feedback and the speaker's data. So I moved that to the root of my application as well. So the provided folder should after that be empty. Let's look into the data folder real quick. So I have all speakers information already in there, including the artwork for a given speaker and a short name. And I also have a feedback JSON file with all the feedback that we received so far. Let's real quick open the speaker service, and there you find various methods to retrieve data from the JSON file and return it. And for the feedback service, we also have a method that gets all feedback and one to add an entry. We will use all those methods throughout the rest of the course. And when you look closer into it, you may think that there are more efficient ways to work with this data loaded from a file. Like we could load this data just once and not for every method. I did it like that because I wanted that the logic resembles how you would work with a database to store the data. If you want to build on this course material for a real page, it should be easy to switch to a database later. Speakers and feedback are going to be used within our routes, but I want to instantiate them centrally in Server.js and make them then available to my routes from there. And this is where the way we created the routing handlers before, like as a function, comes into play. So first I start out by opening Server.js, and there I first have to require those two service classes. So somewhere on top I add const feedback service equals require dot slash services feedback service. And the same goes for speakers service equals require dot slash services speaker service. Next, I have to create instances of those classes. So I will now add const feedback service. And now I'm using lowercase because this is a class instance. Const feedback service equals new feedback service. And there I now add the path to the data file. So this is what the constructor expects. Let's look into that one more time real quick. You see that the constructor expects a data file that points to the JSON file. So I add dot slash data feedback dot JSON. And I do the same for the speaker service. So I add const speakers service equals new speaker service. And there I pass in the path to the data speakers.json file. And as I said before, I now want to pass down those two instances of those classes to our routing infrastructure. And for that, I can now simply add an object, so curly brackets, as argument to the routes function. And I will simply add now feedback service and speaker service. So this will pass down those two service instances to the routes. And if you wonder, because the syntax is unfamiliar for class syntax, this is the same as if you would write something like speaker service colon speaker service. So technically that's the same, that's just a shortcut. In my routing handlers, I have to, of course, now somehow collect these class instances. So I go into routes, and in index.js, I can now get this as function argument, and I call this function argument params. And when I save it, Prettier will prettify that and remove the parentheses here. And I pass down those params simply to the speakers and the feedback route. And now we have to proceed in speakers.js, and there I'm using a so-called destructuring assignment. So I'm using const and curly brackets speakers service equals params Yeah, of course, I have to also add params here as function argument. So this is the same as if I would do something like params.speakerService and remove those parentheses. So technically that's the same, but you see already that then ESLint tells me, oh, better use a destructuring assignment. And when I save, it will even do that for me. So let's try using the speaker service right in the index route. So I can now add const speakers equals, and I call speaker service get list, which gives me a list of all speakers. And this is an asynchronous function, so I have to await it. And when I await a function in another function, I have to make this function async. So here for the callback, I now add async in front of it. Otherwise, I cannot await for an asynchronous function. And in the end, I simply will return response. And of course, Express gives us also a method that returns JSON. So I add response JSON speakers. So this will be a proper JSON response with the content of what we got from speaker service get list. And let's do the same for feedback. So I go to feedback.js. Again, I'm receiving params here. And then I will now add const. And again, a destructuring assignment, const feedback service equals params. And we create an async function here again. And I fetch the feedback by adding const feedback equals await feedback service dot get list. This will give us all feedback. And again, I'm returning JSON, and in this case now the feedback. So the application is still reloading, does not show an error. That's already a good sign. Let's try this out. I'm heading into the browser and let's open localhost 3000/speakers. And I get a list of speakers back, and let's do the same for feedback. And here is the list of feedback. So as you see, we now have the business logic in place, and we can now build the rest of the application on it by rendering this information into our templates. While we are at fleshing out the application logic, I want to add one more piece of middleware that is common to web applications and that we will also need a bit later. HTTP is stateless. This means that it does not recognize a user between requests. To persist data for a user from request to request, we need sessions. In my course Advanced Express, I provide detailed insights into how sessions work. For this course, I keep it short and just show you how to install a proper session management system and how to use it. There are various different session modules for Express. We will use cookie sessions. Cookie sessions store the data we want to persist for a user encrypted on the client. This needs to be encrypted because we don't want the user to be able to see and manipulate what we store in that session. The encryption hides it from them. To get started, we will now install the cookie session module. So I'm stopping NodeMon and Express by pressing Ctrl+C, and I will now type npm install cookie-session. And then I can start my application again. And in the server.js, I now add on top, as you expect already, const cookie session equals require cookie session. And then I have to add this middleware to the request lifecycle because it has to fetch those cookies that are sent with the headers that come from the client and parse them and also then set them on the request object so that we can work with them. Right before we set the view engine, I will now add app.use, and the middleware is called cookie session, and I add some configuration object there. The name of the session object should be session, and I can define keys here. So this is a set of keys that will be used then to encrypt the cookies. And there I'm very creative. I'm just putting something in there. It just should be random. Do whatever you want. And I do one more thing. Look closely, because if you deploy this application ever to a web server, and usually this runs behind a reverse proxy like Nginx, then your whole cookie system might not work, because you have to add app.set trust proxy 1. And this makes Express trust cookies that are passed through a reverse proxy. If you don't have that, your whole cookie system might fail then when you deploy to production. And this is really hard to track down. Of course, there are more options that you can pass to this cookie session module, but for what we need, this is completely sufficient. Now, let's find a way to test this. Let's go to our index route. So I open routes index.js, and let's create a very simple visit counter in this index route. So I add now if not request, and now cookie session will store this information on a property called session on the request object, and I want to store the visit count on a property visit count. If it does not exist, I will initialize it now. So add request session dot visit count equals 0. And after that, I can now just do something like request dot session dot visit count plus equals 1. So this will increment the visit count by 1. And below that, I will log out the count. So I add console log, and I'm using string interpolation here, and I add number of visits, colon, dollar, curly brackets, request, or let's copy paste that here, request session, visit count, and I paste it in here. Okay, so far so good. Let's see what happens now. So I open my browser again, and I head over just to the index route, and I run this application. Let's see what we get on the console, and I see number of visits 1. Let's reload it a few more times. And yeah, you see that now the number of visits is at 11. And to prove that this is now really stored for a specific user, so that is not all visits of all users, that's the visits of one specific user, I will now just open Chrome in incognito mode, because the incognito mode starts fresh without the cookies we just set. And I will now simply open the page again. And if we now look into our console, you see that the number of visits is again 1. And if we go back to the regular page and we reload, you see that the number of visits is 12. So it's really specific for a given user. Let's be a little bit more curious. Just let's look into Chrome Developer Tools. And there, let's just reload the page. And right on top, this is where the page actually, the HTML gets transferred. And there you have this tab cookies. And you see that there is this session cookie, which contains this encrypted value. So that is all done by the session handling middleware we just added. To clean this up, let's remove this visit counter. We don't need it going forward. So I'm just removing it from the index route again. This session middleware gives us a working session system so that we can persist data from request to request, and we will use it a bit later in this course. So far, we created one template for the index page. If we look at it, there are parts that will be the same for any subpage. This would be the whole HTML head section with just the page title changing, but also the navigation. The hero section with the large image is something I may also want to show on some subpages. Let's open Chrome Developer Tools real quick, and for that I can just now click right into the page and choose Inspect, because we want to inspect the parts of the page. And if we hover over those sections in HTML on the right side, we see that they get marked on the left side. So we can identify which section we are on in HTML. And there you see that we have this header section with this Jumbotron up there. And then we also have this nav directly below. And then there is an article that contains the speakers list. And if we keep scrolling, we end up at some container. And let's scroll down here on the page as well. And you see that this container contains the content of this individual page. And within this container, we again have also two sections. The first is the left section, and then we also have a sidebar. Everything in this container is specific to a given page. The parts around it are the so-called layout. And the content of an individual page should ideally be loaded into this layout. Some template engines come with some layout concept out of the box. AJS doesn't, but it's easy to build something similar. For that, let's go back into Visual Studio Code. And there I will now create a folder layout inside my views folder. And then to get started, I will just copy and paste my index.js file that I have in pages into layout. Then I open the index.js file in pages again. So careful that you're back on this index file inside pages, not the one inside layout now. And there I will now remove everything that is surrounding my actual content container. And for that, I'm scrolling down, and so here we are at the header section with the navigation. There is the Jumbotron, and we scroll down further. And there we have the speakers list, and the speakers list is something actually that is specific to the index page. So we leave that in. So, and then I'm scrolling further and remove more or less the rest of it on the right side. So here we are. That's still the main content. Scrolling. Here we have the sidebar with the pictures. And then you end up at the section with the JavaScript. And here we can actually remove everything until down to the HTML. And if we save, we also see that Prettier will now fix the indentation. And if you see something like that, so if the div is maybe here on the same level, you most probably just forgot to remove something on top. So then you have to just look at it again and just make sure that the indentations are really nested as you see them here. So this is now really the content of our index page. Everything on there belongs to the index page. Now I save this, and then I go back into the index.js file in layout. And now I'm going the other way around. So now I'm removing everything from the layout that would be specific to a given page. So I'm scrolling down, and I leave the Jumbotron in here. The navigation stays, but everything here, starting with the speakers list way down to the JavaScript down here, is now page specific. Here I'm just making one important change that is key when moving from local static files to a template-based approach. I make the path you see here in line 85 to /JS, Pixscript.js, I make it absolute. So I remove the dot here. This is because the absolute path points to the root of our project when it's delivered via Express, and it will work even when we are on a subpage where the relative path would not point to the right location anymore. We will fix that on various locations while we are creating the other templates, just so you are aware why we are doing that. What's left now is some way to load the contents of a page into this layout file dynamically. And we already learned that AJS supports includes. So we can now scroll up again, and after the header section, we will now insert the template tag, and this is the brackets %, and I'm now using the dash, the minus, because we want to include the template unescaped, because if you would escape it, the HTML in this template would be escaped as well, and you would see basically the HTML show up on your page and not the parsed HTML. So I add now include, And there I'm using backticks because I can use string interpolation here as well. And there I'm now pointing to dot dot slash pages slash dollar curly brackets template. And don't forget to also close this template tag here. Next, of course, we need to change the template rendering function to actually render the layout and pass in the template that we want to be included into this layout. So I'm opening routes, index.js, and there I have my index route with the render in there. And there I will now change the render function to render layout, because that would point to Vue's layout and then default to index.js, and the page title can stay the same. And I will now add a new template variable that is index. That's the template we want to include into this layout. Now I'm anxious if this still works as before. So I'm opening Chrome again, and there I reload the page. And this looks actually pretty good. So we now have a layout-based template system, and it's now way easier and way less redundant to create the other sub-pages using HES. As developers, we know that it often helps to move recurring or just large sections of code into large functional units of their own. This removes redundancies and increases readability and reusability. When creating templates, such functional units are often referred to as partials. When we look at our layout file in Vue's layout index EJS, we see that it's already pretty cluttered with different parts of content. So if I want to change my navigation section, you see that I have to scroll around to eventually find it and do my edits there. So the navigation would be a good candidate to move into a file of its own. So let's try that out. I will now in layout create a new folder, partials. So that's where all our partials should live. And in there, I create a new file, navigation.hes. Next, I will copy the whole navigation section from my index.js file. And you find that here on line 27, you see that there this nav section starts. And if I scroll down all the way, you can follow along this vertical line here as well, because this marks the tag we are actually on. And here the nav tag closes, so I'm cutting that out here. And I move back to navigation.hes and I paste what I cut out before into this file. When I save, the indentations are fixed, and you should as well see this proper nesting as I have it here in my file. While I'm here, I also want to fix all links to actually point to the right subpages, as they will be named later then on my dynamic page. So I'm looking through the file and I see that ./index.html, this is actually the slash path. Here on line 15, there is the same. I will replace that as well. ./speakers HTML should be /speakers. And further down on line 30, again, have a link to speakers HTML. I remove the dot and just call it /speakers. Then we see that there are those drop-down items, and we have this link to Hillary Goldwyn. We can leave it like that because we will make this section dynamic later anyway, so we will fix those links. But we can also fix /feedback HTML to be just /feedback. Let's see if we forgot something. No, this looks good so far. So what's left to do is in my layout index.js file, I of course also have to now add this include. So I'm using the bracket here in the header section after the Jumbotron bracket %, and I want to again include unescaped HTML. So I use this dash, and then I add include ./partials navigation, and I can omit the HES extension, and don't forget to close this tag here as well. Now let's look into the browser. Let's reload the page, and we see that the navigation is still here. And now all the links like to all speakers are fixed as well, and also this link on this RU meetups. now points to the root of our application. Let's look into the layout file again. And we also see that there are plenty of scripts here. And also the scripts here harm readability. So why don't we just also move that out into a file on its own? So I'm cutting out the script section, and in partials I create a new file. And how should we call it? Maybe scripts.js. And I simply copy that part in there as well. Of course, again, I have to now also include those scripts. So I add, and for that I can just copy the navigation part. And after the template is included, so just before the closing body tag, I will now add include partials scripts. Now, if I reload the page, everything looks good still. And we see if the scripts are working by just clicking on one of those images, because PixGrid is used for showing the pop-up for this image. And if this works, then obviously the scripts are included properly as well. And of course, you can always go into Chrome Developer Tools using Inspect and see how the code actually looks like. And you see here that the scripts are again here because they're rendered via include. You already saw that we can make variables available to templates. In our index route, we did that for the page title and also for setting the template that should be rendered with the layout. Template variables are the way to make any dynamic data available to templates, and Express knows 3 different types depending on their scope. First, you can set the variable directly, as we see here on line 10 on our index route. These variables are only available to the particular template for this particular request. Second, Express also knows variables that are globally available to any template for a given request. So they are request global template variables, and they are set on the response object. Typically, you would set that via middleware. So let's try this out real quick. So I go into server.js, and there, after the Express static middleware runs, I now add a new middleware via app use. And you know already, it takes a callback that takes a request, a response, and a next argument. And here on the response object, I can now set something like response, and the variables are set on a sub-property called locals. And here I can just set any variable name like some variable equals hello. So this variable named some variable will then be available to any template, and also, of course, to the layout file. Of course, as for any middleware, I will return next in the end. Lastly, there are also variables that are set during startup of the application and then available for the whole lifecycle. This is done, and you might guess this already, on the application object. So on the application object, there is also a locals property. So I can set app.locals. And here we will start by defining a global template variable that contains the name of the page. So I add app.locals.site name, and I let this be Roo meetups. And I used uppercase for the Roo so that we see a difference when we try it out then later. And to use that variable now, I go into Views, Layouts, Index.js, and there for the title, I will now replace the static site name with bracket, %sign equals, because we want to output something, and I just enter site name here. Maybe let's do a pipe between site name and page title. So let's try that out. In the browser, I will open localhost 3000, and we see that now here up there on the tab that Roo is now written uppercase. So it's coming from the template variable we just set. We also have the name of the site in our navigation. Why don't we also change it there to be dynamic? So I open Layout Partials Navigation, and there I look for the navbar brand class. And in there we have this Roo meetups again. And there I also will simply add site name in template tags. In the browser, let's reload it. And we see that now it's also here written in uppercase, means coming from this template variable. When I look further on my page and into the navigation, and here we have this drop down with speakers, I see that I have a list of all speakers here in this navigation. So it would be cool if we can make this also dynamic, and ideally this should run with each and every request and should then be available to all templates. This means that we could during runtime even change the name of a speaker and it would automatically update. To accomplish that, and I showed that a little bit already, we can go into server.js, where I already created this middleware before. First, let's remove all that is in there in this middleware function. And I added try catch block. And if you're wondering what we are doing here, we will cover Express error handling in great detail later. For now, just follow along. If there's an error, we return next error. And in the try block, I now add const names equals, and we have the speaker service available in this file already because we declare it up there in line 9. So I can now simply add speaker service dot get names. And do you know what I forgot here? Of course, I have to wait on that because this is an asynchronous function, and also I have to make this callback asynchronous. Now to make this available to all templates and also to the layout, I add response dot locals dot speaker names equals names. And to see that what we did actually worked, let's do also a console.log. And let's just output this response locals here, this object, to see if this worked as expected. And in the end, never forget to return next from a middleware. Let's reload the page and look at the console, because as you see here, we have here now this locals object, and this locals object contains one property speaker names with the names and short names exactly as we need it for our navigation. So with these names available to all templates, let's see how we can use it to render the speaker navigation. By now we have the list of speaker names that we fetch with every request and store into a template variable. Let's see how we can now render the navigation from it. For that, I open Views, Layout, Partials, and there Navigation.js. You now already see how much easier things get once the layout has been split into logical parts, because now I am right in my navigation and I scroll down until I find this drop down. It starts at line 29. And there I see that the individual speakers start with line 33. And what I will do now is I separate this out first by adding blank lines, and I will remove this Lorenzo Garcia entry and also the last entry for Mr. Revington, and just leave Hillary Goldwyn in here. We use that entry more or less as a blueprint for the dynamic data we want to render out now. Next, I want to now loop through the speaker names template variable. And for that, I first add the template tag we know already. And I don't use now an equal sign or a minus because I'm not outputting anything. So for a control structure, I just use bracket %. And there, I now start out by adding speaker names. And there I can now call, like in JavaScript, for each on. And as it is with a for each function, this takes a callback that gets for each iteration the current array item. And then I continue as if this would be regular JavaScript by adding curly brackets. So this now looks very much like regular JavaScript. And all I have to do now is to actually close the template tags here and down here. I close that so that EJS knows that this has to be parsed as JavaScript. And then I take the more or less blueprint, this one entry that we kept, and I copy that into my loop statement here. And in this loop statement, I now have this speaker variable available, the loop runner variable, which will for each iteration contain another speaker. So I will now simply change everything that's static here to be dynamic and also represents our dynamic page. So for the speaker link, I now add speakers slash, and this should point to the speaker.short name. And in the console, you see speaker names array as well. So you see that there is a speaker property for each speaker. And I also want to output the full name. So I copy, paste this block I have here on the link. And here I change it to simply be speaker.name. So this should be it. Let's head over to the page and reload it. And when we now look into the speaker array, you see that the links are now correct. And we know that this list of speakers is fetched for each request. So when we go now into our data speakers JSON file, and I change Lorenzo Garcia to be Lorenzo Garcia III, and I reload, this is now directly reflected in the navigation. We also see that it's not reflected yet in this section with the top speakers with the pictures, because this is still static. So what we are going to do next is we will make this dynamic as well. And as this is only used on the index page, I will also fetch this information just for the index page. For that, I go back and let's first go into server.js and remove this console log statement we had before. We don't need it anymore. But I will now go into routes, index.js, and there I first have to get the speaker service, and you should know already how this is done. So I add const speakers equals parent. Next, I want to fetch the speakers list, and in this case, the speakers names won't do because we also want to have the title of the talk of the speakers, and we have a method for that. So I now add const top speakers equals, and now we await again. This means we have to make this callback function here async, and I add speakers service, and there is a method called getList, which will give us the complete speakers list, including the title of the talks. And to also see that, let's do a console log here, top speakers. And we also want to, of course, make this variable now available to our template. So add top speakers to the second argument object. Let's reload the page so that we get this list content to know how this object looks like. And you see that we again have name, short name, but also the title of the talk and the summary for the talk. To use this data now, I open now pages index.js, and there on the very top, we have the top speakers list. And as you might already have guessed, this is a good candidate again to factor out into a file on its own. So I will now just copy that whole article at the very top, and I will create in pages a new folder, partials. And in there, I create a new file, top speakers.js. And I paste the content in here. And back in my index.js file, I now have to add the include. So I add the bracket percent, again with the minus, because I want to have unescaped HTML here. And I add include dot slash partials top speakers. Let's reload the page and see if everything still works, and it's looking good. Next, let's open top speakers again. And of course, we now want to render this dynamic content into that. So we want to render list again. And this is now just a little bit more complicated because there is more content in here. And we now have to separate out where such a speaker entry starts and ends. And we see that this is actually this call MD text center that defines a speaker. So we can separate it out by creating a empty line here. And if you look a little bit closer, those entries are not the same for some reason. So our designer was a little bit careless here. So you see that we have here a div for the speakers list info, but further down we have a paragraph for the speakers list info. I'm removing this first entry. I will stick to the paragraph because all other entries are using the paragraph here. And we now want to render the list here as well. And this is just a little bit more complicated because there is just more content in there, and we have to figure out where such a speaker entry starts and ends. And if we look a little bit closer, this is actually this call MD text center that defines one speaker. So I can separate this out here. And further down again. So these are my speakers entries. Now let's remove all entries but one, and let's save to make sure when it's formatted that the nesting of the diffs is still correct, and it is. And I will now again, as we did it before, traverse a list. So I use bracket percent, top speakers, and for each. And in there I have again this callback function that gets each element of this array as an argument. Again, add these curly brackets, and I should not forget to close the template tags also here on this line above. And then I will just copy this speakers element into this loop statement. And as before, this will now loop through the speakers, and for every iteration I have now access to the current speaker object. And for the title I can now add bracket percent equals speaker dot title. You see it here on the console as well. So as a reference, we see also how this object looks like. And further down for the speaker name, I add speaker.name. And we also have to fix the links for the speaker. So this is then slash speaker and the speaker's short name. And when you look a little bit further, we need it again because there's also a link on the image. So I copy paste that here for the image link. And if you look how the image source actually looks like, it uses the speaker short name just with an underscore TN for thumbnail and then JPEG. So I can derive the URL to the speaker's image from the short name. The only thing I want to fix here as well is to use an absolute URL here, and then I can insert the speaker short name here. So this will then point, and if you don't believe me, you can also look into static images, and there you see speakers, and there you see the short name always appended with underscore TN. So this will then point to the right image. Also, you see the alt text, and we want to have the speaker name in there as well. So I change Hillary Goldwyn post also into a template variable. Let's see if we have anything static left. No, I don't see anything. Looks good so far. So let's reload the page and see if this works. And you see now that we have this Lorenzo Garcia III. So this means this was now rendered directly from a JSON file. We now decided that he is actually not Lorenzo Garcia III. So I go back into speakers and remove this entry here and reload. And you see that it gets dynamically updated. Let's hover over the links, and you also see that the links are now correctly pointing into /speakers. So we are now way closer to having a dynamic website, but when we try to get to speakers, all speakers, we see that there is no template yet. So let's go ahead and create templates for the speakers list and also for the speakers detail pages. So far, we only have the index page template ready. Now it's time to implement some more pages. If we look at the static page, we see that there is a page that shows all speakers. We created the route for that already. When I click on a speaker, I get to their profile page. And when I look at this profile page, it contains a large image, just the artwork for this given speaker, and then some detailed information about the speaker. Such a pattern of list and detail pages is very common, and we need to find a way to let Express know which speaker it should show on a detail page. Such a pattern of list and detail pages is very common, and we need to find a way to let Express know which speaker it should show on the detail page. And this is where parameter routes come into place. Let's implement the speakers list template first, and this should by now look very familiar to you. And there I look into my static folder, and I will take the speakers HTML file and I copy it into my Views Pages folder, and then I rename speakers.html into speakers.js. Next, I'm going to remove everything that is part of the layout. So this is everything down to this line 46 where we have this container empty4. Then I'll look for where the JavaScript tags start, and I will remove that as well down to the HTML. Then, as I mentioned before, we have to fix those image links to be absolute, but we will take care of this artwork sidebar anyways later, so we can leave it as it is right now. Next, let's change our route to render this template. So I take the route we have already in index.js, and there I remove this console log statement already and copy our index route because it's very similar to the speakers.js file, and I replace what we have in here now for this slash route. The only thing that changes is that these are not the top speakers, they're just the speakers. The get list statement stays the same, and I will just pass speakers as variable to this template. And of course, we have to change the template that we want to render, and it's now the speakers template, and the page title should be speakers. Let's see if this works already. So I go into my browser to the page, and there I use the navigation and click on speakers, all speakers. Okay, this looks good so far, but it's still just a static placeholder content, and we will replace it now with dynamic content. So in my speakers AJS file, I now have to again identify where those individual speakers entries start. And I can do that also by, again, in the browser clicking inspect. And we see that one particular speaker is always this div class MB4. So that's easy. So I look for this div class MB4, and it's here. And I just select one entry that I will use as blueprint, and I can remove all other entries. This goes down to where the article HTML tag is closed. So this, what we have left now, is one particular speaker. Let's see if this is correct by just reloading the page. Yes, this looks good. Next, we are going to use the loop statement we had before. So we add speakers. Next, we are going to do something very similar to what we did before for the top speakers. So I add speakers dot for each. And again, we get this callback function, and this function gets the current speaker from the array for each iteration. Let's close the template tags here and also up here. And I take now this one speaker entry and paste it into this loop statement, because as you know, now we have this speaker as variable available for each iteration. So I can now again change what we have in here to speaker.title, and I copy that because I'm lazy, and I change the name to be speaker.name. And of course, the URL has to be /speakers /speaker.shortname. And down here also there is a placeholder for Lorenzo Garcia. I just replaced it with /speakers shortname. And also the image link needs to be fixed. First, it should be absolute. And I also want to put the short name here. And the alt text should also contain the real name of the current speaker. And down here we have the summary for a given speaker. And I know that this is stored in speaker.summary. Again, there should be no static content left. And this looks good so far. So let's see what happens when I reload the page. And we see that this is looking good now. So we have now the real speakers list rendered out here as expected. So this is now a dynamic page as well. With the speakers list in place, all that is missing now is the detail page. Let's again click on one such link in the speakers list, and you see that we end up on a page that contains the short name of a given speaker. And we want to now create a route that shows the detail page for a speaker by a given short name. For that, I open Visual Studio Code again, and I first want to implement this route. So I go into speakers, and we now need some way to get the speaker's details by the short name. And you see that we have a parameter route here already that gets the short name. I now start out by adding const speaker equals await. And of course, I have to add async to the callback here. And I'm using the speaker service here. And now I need a method that gives me a speaker by their short name. So let's look into speaker service. And there on line 68, you should see this method. So it's get speaker and it takes the short name as argument. Back in Express.js, I will now just call get speaker. And do you remember how we get to this short name? It's in request.params.shortName. So all request parameters are in request.params. Let's do a console log for this speaker so that it's later easier to output everything inside the template. And of course, we want to render now a template with a layout. So I copy this render function from the regular slash route and paste it here over. And I, of course, want to render another template. It should be then speakers dash detail. And it gets the current speaker as an argument. Of course, we now have to create the speakers detail template. So I look into my static folder, and there I have this Hillary Goldwyn HTML file, and I copy that over into my pages folder. And I rename it to speakers-detail.js. And now, very similar to what we did before, we remove everything that we have here until we reach this container statement, and then we scroll down to find where the JavaScript starts and remove everything down to the HTML. And here in this file, we now have this speaker template variable, and we have to now just use that to replace all static content with the dynamic content. So I add brackets % equals speaker.title for the title. Let's copy here again. That's the speaker name. Then also let's fix the links. It's slash speakers slash short name. Down here again, slash speakers slash short name. And for the image, I now don't have the thumbnail, but the big version. So it's just the speaker short name.jpg. And I also have to fix the alt text to be photo of speaker.name. So let's now see how we get this information. We see that this is a long information now, not the summary we had before. And we added a console log, so we just have to reload the page. We see already that it works. So now, but there is still the placeholder text in there. So let's see how this property is named, and it's named description. So down here, I remove this paragraph and I add speaker.description. Let's reload the page and see what happens now. And we see that a few things are wrong actually here. So the top large picture is missing, the artwork is not working, and if we scroll down, we also see that the HTML is rendered, because when we look into the description, we see that this actually contains paragraph tags, and they now show up in our HTML page. Do you know what's wrong here? Exactly, it's the equal sign that we are using here, because we escape HTML. And as said a few times before, if you escape HTML, HTML tags will then regular show up in your page. So if we change this to a minus sign and reload that, see that this is now rendered correctly. Still, we have some more problems on this page. So the artwork on the left side is not showing, and also this Jumbotron with this big picture on top is also not showing up. So something is still really wrong, and also the styling is somehow off. So let's look into Chrome Developer Tools. Let's reload the page with the network tab open, and we see that there are few things are not loading, and most importantly, our style sheet is not loading. So it does not find the style sheet. And if we look closer under which directory the browser is looking for this style sheet, it becomes pretty clear. We see that the path to the style sheet is simply wrong because it's under /speakers, and that's obviously not where the style sheet is. When we look into our static folder, this should be under /CSS. So what happens here? This happens because we are now under /speakers /Lorenzo Garcia. So that's one level down. And this is pretty similar like any regular directory structure. So we are one level too deep. And somewhere we seem to have a relative link that now points into speakers and not to the root of our web server. So let's look into the layout file if we can find this problem. So in layout, index.js, let's see what's wrong here. And if we scroll down, we see that the path to the style sheet actually is relative. And this causes this whole problem here. So if I change this path to be absolute and reload the page, it works again. And also the whole styling is correct again. What's still missing is the artwork, but let's work together to fix that in the upcoming challenge. Our site is now pretty complete and dynamic, but one thing that is clearly still missing though is the sidebar with the artwork. You see that here on the detail page, it's even broken. And if I look at the static page that we got in the first place, I see that the index page contains a left sidebar with all the artwork of all speakers. The same is true for the speakers list. But when I go into one individual speaker, I see that it only shows the artwork for this particular speaker. Also, I see that regardless of the page, the caption artwork on display on top stays the same everywhere. So it's the same here on the speakers detail page, but also here on the index page. Let's take the challenge to first move this artwork section into a partial and then make it dynamic. For that, we of course need a way to get the artwork for all speakers and also for a specific speaker using their short name. Let's go into Visual Studio Code and look into the speaker service class. So I open services, speaker service, and when I scroll through it, somewhere around line 36, you see this get all artwork method. So this will give us all artwork for all speakers. And if I scroll further, I also see that there is already a method called get artwork for speaker that takes a short name and only gives me the artwork for a particular speaker. To understand this a little bit better, let's also look into the data that gives us that. So I open data speakers JSON, and there you see that each speaker has some array with artwork attached to them. So with that knowledge, you should now be able to take this challenge. You, of course, have to change the routes to fetch the right array of artwork. You have to provide them to the templates, and you have to factor out the artwork on the sidebar and also iterate through the array of artwork items to create the list that we see on the page. Mistakes happen, be it some syntax problem or a failed database call. Your application will run into errors, and if they aren't handled gracefully, the question isn't if but when some error will take down your website and you get an angry call from a client. There are a few patterns and good practices to gracefully deal with errors in Express. We've already learned that in Express, each middleware function can either send a response which ends the request cycle or call the next middleware in the chain using next. But what happens when an error occurs inside a middleware or route? Let's try this out. So I open server.js, and in there I will just create some route that simulates an error. I do this right after the Express static middleware. I add app.get/throw, and this gets, as we know, the request, response, and the next argument. And in there, I will now use the regular JavaScript function throw new error, and I say something did throw. Let's open the browser to run this route. So it's /throw localhost 3000/throw. And we see we get the error message, and we also get the so-called stack trace. It's not pretty, but the application is still running. So when I head back to the index page, I see that everything is still generally fine. In my console, I also see that the error was logged out here. So that's the default provided by Express. So using throw would be a legit way to report an error. When something goes wrong, just throw an error and Express will show some error message. This is true as long as you aren't in an asynchronous invocation. I show you that by simply using setTimeout. That's an easy way to simulate asynchronity in Node.js. So I will create a setTimeout function here, and I move this throw statement into setTimeout. And this should run after, say, 500 milliseconds. Let's open this throw route again. And we see that now we get a pretty solid error. So this site cannot be reached. And when I look back on the website, on the index page, I see that the page is down. Looking into Visual Studio Code again, I see that Nodemon tells us that the app crashed. So as we see, throwing from an asynchronous invocation will crash your app. And this is obviously something you want to and have to avoid. So how can we return errors from asynchronous invocations? This is where next comes into play again, because next accepts an error as first argument. So if I now run into an error in this timeout function, I can simply do a return next, and I don't use throw anymore, but I just return the error object here. And when I head back to my /throw route, I see that we get now a proper error back. The stack trace is shorter because it's in an asynchronous invocation, and there Node.js does not see so much of what happened before. So as we learned now, a general rule is to never throw from your Express routes and middlewares because it can take down your whole application. Nowadays, we also have async await, and we use this a lot throughout this course. With async await, we don't have a callback as we have it here in setTimeout, and we need another way to handle errors that happen in this asynchronous invocation. So to try that out, we can just use the middleware that we created before to get the names, and I remove this row route again. And I will just now go into this getNames function, and I will throw from there. So in this map function, maybe that returns us the speakers, I will now throw an error, throw new error, and I call it async await error. Next, let's reload the index page. And we see that the application hangs completely. So this is bad again. Application not reachable, completely broken. So what happened here? When I look into the error message on the console, I see that I get an unhandled promise rejection warning. This means that we got an error, but it was not properly handled. So how can we handle that? In server.js, I will now use a try catch block. So add try catch. You should be familiar with that. So that's regular JavaScript, and all the code goes into the try block. But if something goes wrong, I end up in the catch block, and there I get an error object where I can now simply do a return next error again. Let's reload the page. And we see that we get now this async await error. It's still not pretty, but it does not take down our application. Next, let's apply what we just learned to the routes we already created. So I go to the index route, and there I will now create a new try catch statement. And I copy over all this whole code block into the try block. And if an error occurs, I return next error. And I have to get next as function argument here, because I only had request response because I was not using next yet. This looks good, but now ESLint complains we now also have to return from the try block. I do the same now for the speakers route. Again, a try catch block. And there I move the code over here and do a return next error. And now you should know already how this works. I'm doing that also for the speakers detail. So while we're doing that, we have the good feeling of making our app really resilient to any error that could occur. And I return from here as well, and all that. And I also have to get this next callback as argument. And finally, let's do this also for feedback. So always when you see an await statement in a route, it's a good call to use try catch to handle a possible error within this asynchronous invocation. So now our application is way more resilient to errors than it was before, but we also saw that this default error page by Express is not really pretty or user-friendly. So if a user runs into that, they will most probably think someone is terribly wrong with the website. We should find a way to override the Express default error handler and show something more pretty to the user in case something happens. And we will do that right now. Mistakes happen, be it some syntax problem or a failed database call. Your application will run into errors, and if they aren't handled gracefully, the question isn't if but when some error will take down your website and you get an angry call from a client. There are a few patterns and good practices to gracefully deal with errors in Express. We've already learned that in Express, each middleware function can either send a response which ends the request cycle or call the next middleware in the chain using next. But what happens when an error occurs inside a middleware or route? Let's try this out. So I open server.js, and in there I will just create some route that simulates an error. I do this right after the Express static middleware. I add app.get/throw, and this gets, as we know, the request, response, and the next argument. And in there, I will now use the regular JavaScript function throw new error, and I say something did throw. Let's open the browser to run this route. So it's /throw localhost 3000/throw. And we see we get the error message, and we also get the so-called stack trace. It's not pretty, but the application is still running. So when I head back to the index page, I see that everything is still generally fine. In my console, I also see that the error was logged out here. So that's the default provided by Express. So using throw would be a legit way to report an error. When something goes wrong, just throw an error and Express will show some error message. This is true as long as you aren't in an asynchronous invocation. I show you that by simply using set timeout. That's an easy way to simulate asynchronity in Node.js, so I will create a set timeout function here, and I move this throw statement into set timeout. And this should run after, say, 500 milliseconds. Let's open this throw route again. And we see that now we get a pretty solid error. So this site cannot be reached. And when I look back on the website, on the index page, I see that the page is down. Looking into Visual Studio Code again, I see that Nodemon tells us that the app crashed. So as we see, throwing from an asynchronous invocation will crash your app. And this is obviously something you want to and have to avoid. So how can we return errors from asynchronous invocations? This is where next comes into play again, because next accepts an error as first argument. So if I now run into an error in this timeout function, I can simply do a return next, and I don't use throw anymore, but I just return the error object here. And when I head back to my /throw route, I see that we get now a proper error back. The stack trace is shorter because it's in an asynchronous invocation, and there Node.js does not see so much of what happened before. So as we learned now, a general rule is to never throw from your Express routes and middlewares because it can take down your whole application. Nowadays, we also have async await, and we use this a lot throughout this course. With async await, we don't have a callback as we have it here in set timeout, and we need another way to handle errors that happen in this asynchronous invocation. So to try that out, we can just use the middleware that we created before to get the names, and I remove this row route again. And I will just now go into this get names function, and I will throw from there. So in this map function, maybe that returns us the speakers, I will now throw an error, throw new error, and I call it async await error. Next, let's reload the index page. And we see that the application hangs completely. So this is bad again. Application not reachable, completely broken. So what happened here? When I look into the error message on the console, I see that I get an unhandled promise rejection warning. This means that we got an error, but it was not properly handled. So how can we handle that? In server.js, I will now use a try catch block. So add try catch. You should be familiar with that. So that's regular JavaScript, and all the code goes into the try block. But if something goes wrong, I end up in the catch block, and there I get an error object where I can now simply do a return next error again. Let's reload the page. And we see that we get now this async await error. It's still not pretty, but it does not take down our application. Next, let's apply what we just learned to the routes we already created. So I go to the index route, and there I will now create a new try catch statement. And I copy over all this whole code block into the try block. And if an error occurs, I return next error. And I have to get next as function argument here because I only had request response because I was not using next yet. This looks good. But now ESLint complains we now also have to return from the try block. I do the same now for the speakers route. Again, a try catch block. And there I move the code over here and do a return next error. And now you should know already how this works. I'm doing that also for the speakers detail. So while we're doing that, we have the good feeling of making our app really resilient to any error that could occur. And a return from here as well, and all that. And I also have to get this next callback as argument. And finally, let's do this also for feedback. So always when you see an await statement in a route, it's a good call to use try catch to handle a possible error within this asynchronous invocation. So now our application is way more resilient to errors than it was before, but we also saw that this default error page by Express is not really pretty or user-friendly. So if a user runs into that, they will most probably think someone is terribly wrong with the website. We should find a way to override the Express default error handler and show something more pretty to the user in case something happens. And we will do that right now. Right now, the error page we get is the default view provided by Express. You will agree that this does not look very professional. The page looks pretty broken, there are no links back to safer grounds, and the user that ends up there will likely leave. We should change that now and add a more professional page that doesn't look as if the server has just crashed. So I looked around to find some clean and neutral error template, and what I found was that one. As you see, this is very clean, very neutral, and also very simple, and I want to use that now as my error template in my application. So for that, I first click on HTML, and we see that it uses Bootstrap already, so there is not much to do for us. I simply take this snippet now, I copy it. Let's see if we have CSS as well. Yeah, there is some CSS to set as well. And I will go into Visual Studio Code. There you see that I created some demo error in the index route. We will have to remove that later, but now I will just open Views, and in Views I will just create a new file on the top level, so not in pages, that I call error.js. And let's put the regular HTML around that, because what we have is just a snippet, body, and into the head tag add a title tag, and let's say an error occurred. And into the body I paste now what I copied from the page before. As we saw, we also have to set some style classes here. So I just copied it as well. And in static, I create a new file, error.css, and I paste in this snippet as well. And for the error page, I have to, of course, now include this style sheet. So I add link rel equals style sheet, and href is /css error.css. So we have now an error template, but where is the render function for the error page? Right now, we are using the built-in functionality of Express. To change that, we need to create our own error handler. First, we want to catch errors that occur when no route matched our request. So I can simulate that by simply going to a page and accessing a subpage called hello. And as you see here, I get this cannot get hello, and this is, when we reload the page, a 404 not found error. So let's create the middleware that captures this error. And for that, I now head into my server.js file, and there at the very end, so this means after all route middlewares were running, when we end up here, it's obvious that no route did match. As we know, routes are handled in order. If we end up at this last route, no other route did match, and there I just add request response and next. And there I want to actually create an error object, the proper HTTP error. And I can do that with a simple helper module provided by Express that I will install now. So I add npm install HTTP errors. Now I'm requiring this module, so I add const and I call this create error equals require http -errors. Now I'm scrolling back down to my middleware function, and in there I will now return next, create error, and it should be an error 404 because it's a not found, and the message should be file not found. So this will now trigger an error for 404. Let's start Express again and see what happens. Yeah, now I get a not found error with a file not found. So that's exactly what we expected. Now we have to create the real error handler, so a handler function that will render the right template for us. For that, Express has a convention to know which function is actually the error handling function, and this is a middleware that takes 4 arguments. So a middleware that takes 4 arguments is the error handling middleware. So for that, I add app.use, and now the first argument to this middleware is the error. And then I go on with request, response, and next. So this is now an error handling middleware just because it takes 4 arguments. And in there, I will just now populate my template variables by adding response.locals.message. This should be the error.message, because that's an error object that usually contains some message. Then I add const status, that should be the status code, is either the error.status, or if we don't get any error status, let's default to 500. Let's default to error 500, which is an internal server error according to the HTTP standard. And I also want to set this status now as template variable, so I add response local status equals status. And we will now also set the status on our HTTP response. So I add response.status and I set it to the status we just defined. So our response will contain also the status code of this HTTP request, be it 404, 500 or whatever. And in the end, all I have to do is response.render, and there I want to render error. Now I'm almost anxious to see how the page looks like, so let's go back to the browser and let's reload. And this looks almost good, but we are missing something here. Let's go back into our error template, and there we see that we are missing the statements that actually include Bootstrap. So I head back to the template. Let's see where it is. And as you see, that's here on top. I will just include the Bootstrap CSS and paste it into a snippet as well. When we reload now, we get this beautiful error page back. As you might have figured, this is still not dynamic because that's still a static page. So we will now have to apply our template variables. So I go back into the error template, and in there I will just add my template tags. So for 404, I replace that with bracket % equals status. And for the message, I output the error message. So let's head back into the browser. Let's reload the page. As you see now, we get this proper error message. And when we go back to the index route that contains another error, we get 500 and some errors. So the error message that we defined before. What I'm not showing here is the actual error stack trace as we saw it before, because it's a pretty bad practice to show that to the user because it may contain sensitive information. So what we can do instead is we can go into the error handler again and just add a console.error, and there we output the error to the console so that when we look into a log file, we see which errors occurred, but we don't show them to the users. So let's reload again. And let's look at the console. And as you see, we get the error message with a complete stack trace on the console, but we don't leak any information to our users. So now we have a proper and pretty error page. Before we proceed, let's remove this error from our index page so that everything works again. Let's try that. I reload, and we have a beautiful working page again. Before we can implement the feedback page, we of course have to do the template for it first. Creating this template is very similar to the templates we've created before, and by now this should be very familiar to you. So let's do this one real quick in a more ad-lib way. Feel free to stop the video and try it out on your own first. So I have the static page open here. Let's look at it in Chrome Developer Tools real quick, just to see where the content is starting. So you see that there we have this main content and then feedback, but way up before there is this container with the content that we had before for the other templates. So I go into Visual Studio Code. There I open my static folder, and there we have a file feedback HTML, and I'm now copying that into Fuse Pages. And now I'm renaming the extension to HES, and then I again scroll, select everything until I reach the container after the header section, and I can again remove everything starting with the script. So this is for now the static template. And of course also need a render function for that. So I go into routes, feedback.js, and let's make our life easier by just copying the index route, because we have this nice render function in there already. And I go back to feedback, and for this slash route I now add the content I copied before, but I'm removing the artwork and the top speakers. We don't need it here. So let's remove that as well from the template variables. And the page title should be feedback, and the template is feedback in lowercase. While we are here, we can also already make the feedback items available to the template. So I'm going ahead and add const feedback equals await feedback service dot get list. Get list will give us the list of feedback items, and I will pass that as template variable. So now we have the feedback items available to the template. So let's head over to the feedback template, and there we have this right menu bar, and again we have there the feedback items. So starting here on line 52, we have class feedback items, and in there are elements called feedback item. And what I will do here now again is I remove all the items except one that we will use as a blueprint. Let's find the right div. That's the hardest part, just to get that right. And when we save, we see, yeah, that works well. So now I again will do a loop statement. So I add feedback dot for each function, and this function gets one feedback item per iteration. And again, I just act as if it was regular JavaScript, and I close the template tags. And then I'm taking this whole block of feedback and I'm pasting it into this loop. Now I'm wondering how those feedback items look like, and I can easily just look into my data folder, and there I see the feedback JSON file, and you see we have name, email, title, and message. We won't print out the email, but we will show everything else. So I will now just change the feedback title from being static to item.title. Then we have the name. So I replace the name chain with item.name. And then I also want to replace the message, so it's item.message. By now, everything static should be gone and it looks good so far. So let's head over to the web page and let's go to feedback. And you see that we now get this data directly from the JSON file. And as a proof, just in case you don't believe me, let's go into data, feedback JSON, and let's say it wasn't Frank, but Jim that made this feedback entry. When I reload, you see it's Jim now. So we added everything to render out the feedback template and also to show feedback items. What we need now is the functionality to post new feedback to the page. So far, we've created a dynamic website that could display content that comes from some JSON file, but maybe also stored in a database. One reason to even create a dynamic website in the first place, though, is that we may need to handle user data in the one or the other way. In our case, we've got a form that allows users to submit feedback to be displayed on the page. We've already created the template for that, and let's look at this real quick. So I'm opening Visual Studio Code, and I open feedback.js. We can see that there is a form in there already, but it misses a few things. First of all, I hope you know HTML, it needs a method. So I add now the form method, and I want to send this form via post request, which is very common for any type of form. Then I also need an action. So that's the URL the form data needs to be sent to, and I want to send it to /feedback. So that's the post route we created at the very beginning. Then I also have to name the form inputs. That's something no regular designer will do for you. So I now have to just go to the input fields, and there I add name equals, it's name equals name. Then for the email address, it's name equals email. So that's the name of the form element. Then we need a title. So I add name equals title. And then we also want the message. Its name equals message. Now let's reload the page and let's fill in something into this form. Bogus email address. This was awesome. I'm completely amazed. And when I now submit this, I end now on this post route that we created before. But obviously we are not doing anything with the data yet. So let's go into the route handler for this post route. So I open routes, feedback.js, and we want to operate here in this post route. Here is where we have to parse now this data coming from our form. Now, how do we get this form data inside our post route? Express is very modular and out of the box quite bare metal. To make it parse post bodies, we need another module that provides us with the required middleware. It's called body parser. And I have to install that now. So I open the terminal again. I stop my node-mount server with Ctrl+C, and I do a npm install body-parser. Then I head over into my server.js file, and there on top, I will now add const body parser equals require body-parser. You might have guessed BodyParse is a middleware, so it operates now on the request object and it should parse what's on there. So I go down and I will do that right after the cookie parser runs. That is somewhere after line 24. I now add app.use body parser, and the body parser has several sub modules included, and we want to have URL encoded because that is the how such forms are sent. That's the format for that. And there we have to add some configuration And this is extended true. You can just always use it like that. If you're wondering about the configuration options for this body parser, then just look up the module and there you find them all. In most cases, extended true is what you need to have proper form parsing in place. So now let's head back into our feedback route and let's see if we now get data here. So I add now console.log and body parser will give us this data in request.body. Let's restart the server again, npm run dev. Let's reload the page. This posts the form again because we posted it before. And when we real quick also look into Chrome Developer Tools, when we reload the page, we should see on the Network tab that this is a post request. And when you scroll down, you also see the form data that we sent. So this is always helpful if you want to debug the form and make sure that the data is actually sent properly. And now back in our route, you see that we also get a nice object with the form data we just sent. So now all that is left is to operate on this form data and later store this in the JSON file. We can now receive the form data when a form is posted. How can we make sure that this data is complete and also doesn't contain malicious data, like JavaScript malware? Regardless of which measures you take in the browser to validate a form, a malicious user can always circumvent that. In short, you cannot trust data from the client. This means that we need to add measures to the server side to make sure that the data the user sent to us is valid. And for that, we will use the module Express Validator. It makes input validation pretty easy. So I'm just stopping my server again and I type npm install Express-Validator. And in my feedback module, I can now add const and curly brackets because it's again the structuring assignment. Check validation result equals require express dash validator. And this will all make sense to you in a second. Check is a routing middleware. This means it accepts the same request, response, and next signature like any other handler function. And while we are using it, I can now show you how to chain such middlewares. So let's go to the post route, and there I will now add a second argument, just an array. And inside this array, I add now check. And what do I want to check? So check looks into my body, and I want to check the name. Then I want to trim it. This means I want to remove empty characters in the beginning and in the end. Then I want to make sure that the length is at least 3, because I assume that a name should be 3 characters long. Then I'm escaping that to make sure that there is no HTML and JavaScript embedded in this entry. And then I add with message. This is the message that should be returned if there is something wrong. And there I just type a name is required. And that's it for the name. And then I will go ahead and add a new entry. Now for the email. For that, I copy the check for the name. And now I'm looking into the email property on my body. And there I want to first trim. And then I can use is email. So this is a function that makes sure that what the user provided is really an email address. Then I add normalize email that adds some formatting to the email, makes it lowercase. For the message, I add a valid email address is required. I copy the name entry again because we have a few more things to verify. The next thing is the title. And the title should also at least be 3 characters long. And if there is something wrong, the error message should be a title is required. And at the very end, I also want to validate the message. And here, let's say the minimum length should be 5. And the error message is a message is required. So when a request now comes into this route, all these checks will run. And in the end, the next handler will lead to the actual handler function that we created. And in there, we can now check if there were any errors. So I add const errors equals. And now I can use this validation result function provided by Express Validator. And there I pass in the request object. Because if there were errors, Express Validators put some hints on the request object. And first I want to handle the case that there were errors. So I add if not errors dot is empty. So means there were errors. And if there were errors, I want to store those errors in my session object. And we will see in a second why I'm doing that like that. So I create a new object on request session that I name feedback. So this is everything feedback related. And in there, I create a property errors. And then I use a function provided by Express Validator that is on the errors object and its array. So this will give us then an array of errors from Express Validator. And now comes the reason why I have to store the errors on the session object, because to display the feedback page again, we will now redirect to the get route again. So I'm now adding return response dot redirect, and I want to redirect to /feedback. That's in general a good practice because every time you send a form, you want to avoid that a user can just hit the reload button to send it again. And in any other case, we will stay with what we have now. We will modify that in a bit. So let's see what we have now. In case an error happens, the request gets redirected to the get route, to the feedback route. And in the get route, I can now fetch those errors from the session object. So let's go up to the get route here on line 10. And there I now add somewhere before the render function takes place const errors equals request.session.feedback. If this exists, so I'm adding a question mark, then I want errors to be request.session.feedback.errors. And in any other case, errors should be false. And after that, I want to reset this session object. So I add request.session.feedback equals an empty object. So after we stored the errors, let's reset the state. To pass these errors now to the template, you might have guessed it, I'm just adding that as template variable. So now I can head over into my template, and I now want to let the user know that an error occurred. So I go into feedback.js, and pretty much right on top, after this headline send us feedback, I will now add an if statement. So if locals.errors, you know that we have to test existence of variables on the locals property, otherwise we get an error. And this is again pretty similar to any other JavaScript. Just close the template tags. And if there was an error, I will now add div class. And Bootstrap gives us nice styles for outputting such messages. So I add alert, alert, dash danger. This will give us a nice red error box. And then I want to traverse this errors array, so add errors dot for each function error. And again, I'm closing the template tags here properly. Before I start this loop, I also have to create a UL tag, so for the list. And inside the loop, I now add a list item, and this list item contains bracket percent equals error dot message msg. So this is the format how Express Validator gives us the message back on the error object. Now let's start the server again, npm run dev, and I head over to the feedback form again, and there I will just now submit without entering anything. And you see that I get now an error message back. So that is exactly as expected, but also when I go back to feedback, this message is gone. This is because we also reset the session object every time we collected the error object from there. We can try a little bit more, so I add Daniel, but then some bogus for the email, a pretty title, and a nice message. And when I submit it now, we see that we get now the error message that a valid email address is required. So this Express Validator also checked that the actual syntax of the email address is correct. We just learned two things. First of all, we learned how to validate the form, but we also learned how to show proper error messages to the user. And for that, we use the mechanism that propagates this error message to the next request via the session object. And this technique is often referred to as flash messages. All that is left for a working feedback page is calling the respective function to write the user-provided feedback to a file. Let's look into the feedback service for that. So I open Services, Feedback Service, and when I scroll down, I see a function, a method, add entry. So that's exactly what we need here. It just updates the feedback with a new entry. And if you wonder what this data unshift is, this is used to prepend something to an array. Otherwise, we could push it, but then new feedback items would appear in the end, which is a little bit counterintuitive. Let's go back into a feedback route. And of course, we have to add this to the post request. So after the validation did run and we checked for the errors, if we end up down here, we are sure that the data we got is valid. And now I can just add await feedback service dot add entry. Now I have to do two things. First of all, I have to make this callback async because we are waiting here. And I also have to fetch all those items from my body. These items are now sanitized and escaped by Express Validator. And I'm using a destructuring assignment here again. So add const, curly brackets, name, email, title, message equals request dot body. Now all that is left to do is to call add entry with name, email, title, and message. We're not interested in what this add entry gives back to us, so we can just leave the wait call without assigning it to a variable here. And I also want to add now a message to the user that tells them that everything went fine. So add now request dot session. So I'm using this flash message approach again. Feedback equals, and now I just add a property message in there. All right, thank you for your feedback. And now in the end, I just have to do another redirect as we did it before for the error. And of course, I also have to evaluate now the session object to see if there is a message in there. So I simply take this error checking and add a new line, and I want to call this success message. And if there is a request session feedback and request session feedback message, I can store this in this variable, and I pass this as template variable to the template here as well. Last thing is to now also show the success message if there is one. So I go to Pages, Feedback HS, and up here where the error is handled, I add a else if locals success message. And if this is the case, I can output the success message, and I can use this alert class from Bootstrap again. So add div class equals alert, but the type is now alert dash success. So this will give me a friendly green success box. And in there, I just output the success message. So I add brackets % equals success message. Now let's see if this still works. So let's go to the page, and there I enter my name, my email address. This was very nice. I will come again next week. Let's submit it now. And you see that we now get the success message, and also a new item was added to the feedback. REST stands for Representational State Transfer, and it defines a way for creating web services. Today, such RESTful services are the most commonly used pattern for APIs. You find courses dedicated to REST with Node.js in the library. Yet in times of single-page apps, it's such a common use case for Express that I want to cover it in this course as well. In this chapter, we will use some client-side JavaScript and a REST API to send feedback directly to a REST endpoint, and also to update the web page without reloading it. But let's first look at the basics. When we talked about routes, we already touched the topic of HTTP verbs. GET is used when you simply request a page. POST is most commonly used for forms because it allows to send large amounts of data in the payload. PUT is nothing the browser uses, but it's part of the HTTP standard. And delete is also defined in the HTTP standard and not really used by browsers. And there are a few more verbs, but these are the most common used ones in REST services. Now what REST does, it's giving those HTTP verbs a meaning, or how we call it, a semantic. GET requests a resource, POST creates a resource, PUT is usually used for updating a resource, and delete deletes a resource. The main difference between a regular route and a REST route is that the regular route will return you HTML in most cases, but REST returns data, and in most cases this is formatted as JSON. But let's look at an example. Let's say we want to create a simple user management system. When working with data, 3 operations are so common that they got their own acronym. It's create, update, and delete. In short, CRUD. So if I want to request all users, I will most probably make a request to /users, and this will give me a JSON with all users in it. If I want to create a user, I will make a POST request to this endpoint containing the payload for this user to create it. If I want to get a specific user, I will do a GET request to a parameter route which contains maybe something like a user ID. In this case, I used 42. So it's the user with the ID 42. And if I want to now update this user, I will make a PUT request, which is very similar to the POST request. It also contains a payload, but the path I'm using now contains the user ID. So this will now manipulate the user object in the database, for instance. Then, of course, there's also a delete verb that I can use to delete a user with a given ID. REST is very commonly used when creating single-page applications. Simply put, the initial request returns an initial document. This document usually contains a lot of JavaScript, which is then used to actually render the HTML or the content into the page. All subsequent interactions with the websites and the data behind it is done via so-called XHR, sometimes referred to as Ajax. It's an API built into JavaScript on the browser to do HTTP requests. So after that initial request, the page isn't reloaded anymore, but sends data to the backend when needed and is updated via JavaScript using the data received from the backend. As I said before, there are dedicated courses on REST in the library, but for our task at hand, changing the feedback form to send and receive data via REST, you now know everything that you need to know. We've learned the basics about REST APIs already. Technically, a REST endpoint is no different from any other route in Express. The only difference is that it won't return a HTML page, but most likely JSON. I want to create a route now that can be used to insert a new feedback entry. And it should also return the now updated list of feedback items. So let's open routes, feedback.js, and let's start out by now adding a new method, and it's a post method as well. I'm scrolling all the way down, but this should now be router.post, and the endpoint should listen under /API. So it would be /feedback/API. And again, I have a request and a response object, and in there I want to implement my logic. Now, of course, also data sent via REST has to be validated, so I can use basically the same validation rules that I had before for this post route, and it would be pretty redundant to now just copy paste that. So what I'm doing instead is I will now copy this array of validations and just enter a variable instead, and I call this variable validations. Now we just have to store those validations inside this variable. So I'm scrolling all the way up. I can declare this variable even outside of my module export. So I add const validations equals, and then I paste in this whole array of validations. Now I can also use this same variable for my API. So I add this as second argument. So this is exactly the same as before. It just stores all those checks in a variable, and all those checks will then run for each request that comes in. When I look at my regular post route, I also see that I forgot something here. And now that it's shorter and easier to read, we will just add a try catch block here as well. We learned before that we always want to have try catch when we are doing async await. So I'm adding that now here. And if there is an error, I want to return next. Error, and I have to add next as an argument here on the callback function. And let's add this next here on my REST route as well, because we start out with a try catch block here as well. Try catch. If there is an error, we will return next error. And in there, we will now, very similar to the before, start out by const errors equals validation result on the request object, because we also have to check for errors here as well. But differently than before, we cannot redirect the user now because we are not on the browser on this route. So I will now do another kind of error handling. So if there is some error, so the error object isn't empty, I will return response.json, because luckily, of course, Express also gives us a method on the response object that returns a proper JSON string. And there I just return the errors array as errors property. And we will see later then how we can work with that and show the user still an error message. And if everything went fine, we can do something also similar to what we did before. So I'm just copy pasting line 66 and 67, where we fetch the variables from request body and then storing the new entry. And now, of course, this has to be async. And after this was done, after this was stored, I now want to return the now updated list of feedback entries. So I'm adding a new line, const feedback equals await feedback service dot get list. And in the very end, I will return response.json. And I want to return an object that should contain a key feedback. Next, I want to have an easy way to test this endpoint to make sure that this works properly. And for any API testing, I recommend a tool called Postman. And I will really quick install that now. So I'm looking up Postman and I'm downloading the app. You should get a version for your operating system here. Let's open it. This takes a little bit. And then I can start it right away. There I choose to skip signing in. So I just want to use the very simple standard functionality this gives us. So where you see the launchpad, I click on this plus icon and there I select that I want to do a post request and I want to do a post request against HTTP localhost / localhost :3000 / feedback / API. And I have to do a few more settings here because the body should be in raw format and the format that I want to send, that's the very right drop down, should be JSON. And in there, I just create now a typical JSON object. And this object contains name, Daniel, an email, test@test.com, a title, let's call it REST title, test, and a message. This was sent via REST. So let's see what happens when I send this now to the web page. And down there we get the response. And I see that I get an error object back. It acts as if there was no data present actually. So what's happening here? Maybe you can guess that similar to the body parser we needed for forms, we now also need a body parser for JSON. This can be very easily added. So I go to server.js because it's the same body parser, but it now just uses JSON. And I don't have to add any other options here. So I just copy paste and change the module we are using here to JSON. Let's go to Postman again and let's try to send the form again. So I'm sending. And now I see I get an array of feedback back. And the first item is now the item we just added. So we have now a fully functional REST endpoint that receives data via post, stores it, and gives us back the data in JSON. We now want to leverage those API endpoints that we just created to modify our feedback page to send the form to the server using XHR and to update the feedback shown on the page. Technically, we will first load the completely rendered page containing the JavaScript needed for those interactions. From then, all subsequent requests will use the REST API. This combination of initial server-side rendering and client-side updates is very common in so-called single-page apps. As it would be completely out of scope to cover single-page application frameworks like React, Angular, or Vue.js in this course, we will take it easy and use jQuery, a simple but powerful library that lets us do XHR requests and also easily lets us update the page via JavaScript. You find plenty of courses on jQuery in the library if you want to dive deeper into the topic. Our page, in fact, already uses jQuery because Bootstrap relies on it for things like the drop-down menu we have in our navigation. So when we look at the source code of the page and scroll way down, we see that down there on line 201, we are already loading jQuery into the page. And before we move on, I want to show you one more thing. So if I now open the Chrome Developer Tools and I reload the page, I see that we get an error here. So why does this happen? This is because PixGrid that we are using for the artwork gallery has a problem if there is no artwork on the page. So we should find a way to also just load PixGrid when it's really needed. So let's look into Visual Studio Code. And there we already have this JavaScript in views, partials, scripts.js, and in line 16, we see that we are always loading PixGrid. So this is something we can easily change by now adding an if condition. So I could say if locals artwork, because every time when we have an artwork variable in our template, we can assume that there is this artwork gallery. So if this is the case, we are loading PixGrid, but not on pages like the feedback page that does not contain any artwork. Now, I mentioned that I created the JavaScript for the feedback page already, and you find it under static.js. There is a file feedback.js. And we also just want to load it when we are on the feedback page. So what we can do now is I just copy paste this block with the artwork, and then I do something like if locals feedback, because this feedback template variable is only set on the feedback page. And there I will now just load feedback.js. So if we are on the feedback page, this JavaScript is loaded. Let's look back at the page. Let's reload. We see, first of all, we don't get an error anymore for the PixGrid. We also see when we go to the JS tab that we are loading the feedback script here. And let's just real quick look at the page and see if the gallery still works. And this looks good. So as planned, the artwork is also loaded only when we are on a page that contains artwork. With that all in place, let's finalize our feedback page now. We just added the feedback.js client-side JavaScript to the page, and now let's look into this script to understand what it's doing basically. So I go into static.js and there I open feedback.js. And you see those dollar signs here, they are related to jQuery. It's more or less a shortcut provided by jQuery, and ESLint just complains because it doesn't know them. What I want to show you is this function that does this XHR request. It starts in line 55. So it attaches, and this is what jQuery basically does. It attaches to CSS classes or IDs, and there it attaches to the feedback form, and it attaches there to the submit event. So when someone hits submit, we first, in line 57, prevent the default. This means the form won't be sent then via regular means. And then we initiate the post request. So in line 61, you see that we are posting to feedback/API. So that's the endpoint we created before. And starting with line 63, we collect the data from the form using the CSS IDs, the selectors, to get the value out of that. So that's again something provided by jQuery. And then in the end, in line 70, we have a callback. This callback update feedback can now operate on the data that comes back from this post request. So if we scroll up to this update feedback, we do a few things. So in line 9, we empty all status messages that might be on the page. And then if there are no errors coming back, so this is now the error handling. If there is no error, we will first reset the form. So this is pretty handy. We only reset the form when there is no error. We do that because it's so annoying when you fill out a form and there is a mistake, maybe a wrong email address syntax or something like that, and then you try to submit it and the whole form clears. So clearing the form should only be done when the form was successfully processed. So if the form was successfully processed, we can then use the data that we get from this post request, because our endpoint will give us the full list of feedback back. So we can now traverse that and create the HTML needed to replace the feedback list on the right side. So this looks very similar to what we did before on the server side. So we traverse it and then we set item title, item name, and item message. Then in the end on line 34, we will replace the feedback that we have in the page with the newly rendered, with the updated entry that we just added. And in line 36, we also show the success message that came back from the server. If there was an error that this starts in line 37, we will traverse the errors and create an error list and set this to the feedback status element on the web page. Let's look into the feedback template real quick because we have to add there something. So I go to Views, Pages, Feedback HS, because what's missing so far is this feedback status element where we want to render those status messages in. So I add a div class equals feedback dash status. And let's enclose everything related to the status messages here. So what we have in there is still related to server-side rendering, and the form will even still work like that if someone does not have installed JavaScript. So we can leave this server-side rendering of the status messages in there, but we will now use client-side JavaScript to update the page. So I open my feedback page, localhost 3000, and I go to feedback, and I open Chrome Developer Tools real quick to see what's happening on the network side. And there I open the XHR tab up there, because then I see the HR requests. So Daniel test at test.com. I call it SPR for single page application feedback. And I add, this should now work. Let's see if it does. So I scroll down, I click submit, and we see that we are almost there. So the API request is done. You see that here in Chrome Developer Tools. There you see what we are sending. And if I look into response, let's see what response gives us. And this is a little bit hard to see, so I'm clicking on preview. There we see very clearly what we get. We see that we get the whole feedback back, but something is wrong with the success message. So let's head over into the route. I go into routes, feedback.js. So now let's see what's wrong with the success message. And I scroll down to my route. And we see that we don't set any success message here. So what we now have to add is success message. And there we add again, thank you for your feedback. Now, without doing anything, without reloading the page, this should actually work out of the box. So I'm adding a new entry. Let's try again. And this should now really work. Let's submit it now. And now we get thank you for your feedback, because now the API sends the right data, and we also see that pretty well in Chrome Developer Tools. Let's close that. We see also, maybe let's do it one last time. And final message, this page is finished now. And let's hit submit. And you see how nicely everything automatically updates without even reloading the page. With that all done, the page is done. We now have a fully dynamic website. Let's go through it real quick. So everything you get here is dynamic. On the right side, we have the artwork. On top, we have the top speakers and also speakers navigation that is rendered dynamically. We have a list with all speakers, and then also speakers detail pages that will render just the artwork of a given speaker. This whole structure of the web page and what we created, like forms or dynamic lists or galleries, is very generic, so you will come across such patterns in a lot of websites. It should be easy for you to build upon that to create any website you want. Thank you for taking this course. I hope you liked it. In this course, you learned everything you need to know to create basic website with Node.js. If you want to take this further, I recommend you to now take my course Advanced Express, which dives deeper into the internals of Express, but also shows you how to use databases or how to upload files. If something during this course looked unfamiliar, please search our library for it. There are courses really nearly for everything. I post a lot of Node.js related information on Twitter. I'd be happy if you followed me there. And if you ever happen to see me at the conference, feel free to hit me up anytime. See you soon. I'm Daniel Kahn.